second law of motion states that the external applied force is equal to the rate of change of momentum, which is also equal to mass into acceleration. But the point here is, what is the origin of this external force? Like, which agency provides this external force on the body? May I come in? The answer is, external force on a body always arises due to some other body. Please don't disturb me. Why do you always enter my room while I'm recording a lecture? You can take me in your video today. Okay, I allow you. But please behave like a good sister. Okay. Look over there. You can see the book is kept on the table. Now, do you agree when I say that this book exerts a force on the table and the table exerts an equal and opposite force on the book? Do you agree with me? No. Do some experiment on yourself. Now, I have this pen. I'm pressing this pen between my hands. I am exerting some force on this pen. But do you agree when I say that this pen is also exerting an equal but opposite amount of force on my hands? Come on, you can try this. I know this. I think I will be able to feel this force. I have a doubt. What if the two bodies are not in contact? Okay, then drop something. Drop something on the floor. Like I dropped this pen on the floor. This pen falls down because of the gravitational pull of the earth, because earth is pulling this pen. The gravity pulls this pen downwards. But do you agree when I say that this pen exerts an equal and opposite amount of force on the earth? This pen tried to pull the earth towards itself with an equal amount of force. Okay, look here. You know that the gravitational force acting between the two bodies is equal to... Let us suppose that this is mass of the earth and this is mass of this pen. G is the gravitational constant and R is the distance between the center of mass of the pen and the center of mass of the earth. Got it? And the gravitational force that is acting has a value equal to this. Now, in case you do not know this, agree with me for the time being. You know that this force is nothing but mass into acceleration. Now, when I talk about the pen, the force exerted by earth on this pen, here the mass will be the mass of the pen. So here I will be writing this and this gets cancelled with this. So the acceleration of this pen is gm by r square, where m is the mass of the earth. Now let us talk about the force that is exerted by this pen on this earth. Here mass will be corresponding to earth. And in this case, you know that this will get cancelled. The larger mass, that is the mass of the earth, gets cancelled. And the acceleration of the earth in this case is gm by r square, where this m is the mass of this pen. Now compare the mass of the earth and the mass of this pen. Now, do you think that this acceleration will be sufficient enough to cause any change in the motion of the earth? Do you think that this mass of this pen stands anywhere in front of the mass of the earth? Do you think that they both are even comparable? No, absolutely no. It is for this reason that this pen got accelerated towards the center of the earth. Such a motion is visible. But this pen is also exerting an equal and opposite amount of force on the earth. But since the acceleration is only this much, even the earth cannot feel it and we cannot see this. How are you so sure about this? Because he said, wait. He? Who's that he? I'm talking about Newton. So according to Newtonian mechanics, forces can never occur singly in nature. Forces always occur in pairs. Really? The mutual force between two bodies is always equal and opposite. You know that force is a vector. वेक्टर्स क्या होते हैं? दे हैव मैग्नीट्यूड, डायरेक्शन एंड दे ऐड अकॉर्डिंग टू ट्राइंगल लॉ ऑफ एडिशन. ठीक है. अब forces are equal means their magnitude is equal, and opposite means the direction of the two forces will be opposite to each other. Like if one force is in this direction, other will be in this direction. So with this, we are now in a position to state Newton's third law of motion, which states that to every action there is always an equal and opposite reaction. See, I have some doubts. What do you mean by the action and reaction? See, action and reaction mean nothing else but force. The action and reaction terms used here might confuse you, but they mean nothing else but force. So, if this is a rigid surface and I have kept some body over here which is having, say, mass m. Now the force acting on this body m, because of this rigid surface, is in this direction, and the force acting on this rigid surface because of this mass m is in this direction. So when I draw a free body diagram, so what is a free body diagram? In a free body diagram, what do? Is you take one body at a time and write down all the forces that are acting on that body. For example, if I consider this is a complete system. This is a complete system. But if I want to calculate the forces acting on this body of mass m, I will be drawing its free body diagram, wherein I will be taking this as a separate entity, and this mass m is experiencing a normal force in the upwards direction because of this rigid surface on which it is kept. Another force that is acting on this body of mass m is the gravitational pull of the earth, which is mg. If this mass is at rest on this rigid surface, the two forces balance out each other such that this object of mass m is at rest. Now, if I draw a free body diagram of this rigid surface, we have this equal amount of this normal force acting on this in the opposite direction, like this. This is the force experienced on this rigid body because of this mass m, which was kept on this surface. And if this rigid surface is, for example, a table, and there will be normal forces because of the surface on which this table is kept. So this will be another normal force, which is, say, n dash, and another force will be gravitational pull of the earth, which is acting on this table. I've mentioned it with capital M, and all these forces will balance out each other because there is no motion of this table in the vertical direction. So this is the free body diagram of this block of mass m, and this is the free body diagram of the surface on which this block of mass m is kept. So if this is the body A and this is body B, force on body A because of body B, which is this force, is equal and opposite to the force on body B because of the body A. Forces always occur in pairs. This is important. Forces always occur in pairs. Now this normal force is nothing but force on A because of B. I can write it like this. This is A and this is B. The force on A because of B is this normal force, and this normal force I can write down like force on B because of A. This is how I write it. This is a kind of cause effect relation, I guess. कि पहले एक्शन होगा और उसके जवाब में रिएक्शन होगा. So first action has to be there, and then in response to that action there will be a reaction force. Now this statement can be misleading. To every action there is equal and opposite reaction. You might think that first action has to take place and only then the reaction comes. Here you need to know this, that these two forces, they occur at the same instant. the action and reaction pairs, they occur at the same instant. They both will occur at the same time. So what do we conclude from this? There is no such thing like action and reaction. I can say this as action and this as reaction, or I can say this as action or this is the reaction, because both of them are occurring at the same instant. Let me give you a demo. You shut up. Get lost. Okay, one last question. Do this action and reaction forces, this action and reaction pair, do they act on the same body? This force is on A and this force is on B. The action and reaction forces always act on two different bodies and not on the same body. You cannot put this force over here and cancel out these two. However, it is to be noted when you are considering the system as a whole. For example, if I am considering the system as a whole, the surface and the block together, then in that case, the free body diagram will be corresponding to the system. Here I will be writing all the forces that are acting on the system. In that case, these action-reaction pairs, these form internal forces. Like this is the system as a whole and the normal forces. In this case, they become internal forces, and being equal and opposite in direction, they get cancelled out. So this depends upon the way you are solving or handling a physics problem. If you are considering the motion of the individual object, if you are interested in individual object, you will be drawing the free body diagram of that individual object separately. However, if you are considering the motion of the system as a whole, then in that case, these action and reaction forces will become your internal forces, and they will add up to 0 because they are equal and opposite in direction. So this law can also be stated in another way, that the internal forces in the system cancel away in pairs. चल बहुत हो गया अब तेरा. That was all for today. I hope you liked this video and it was informative. Do not forget to like this video and subscribe to my channel. I've also created an Instagram account. You can follow me there as well. You know I will be back with my next video. Till that time, do not forget to take really good care of yourself.